Welcome back to KEDCO on the Street. Our next guest needs the power of the sun to make many of his technologies work. I'd like to welcome Ben Stinson, the managing partner for QSBR Innovations, Inc. Thanks for being here, Ben.
Thanks very much.
So tell us a little bit about this technology, because it really deals with solar power, doesn't it?
Yeah, actually, we have two technologies, one of which is for solar thermal systems. And what it does is it regulates the temperature in a solar thermal panel. The panels are designed to get very, very hot, which is wonderful when you're using them, but if you're on vacation or if there's a power outage, the temperature keeps rising and there's no load for it to use. And so what we've got is a technology that allows the ambient air around the solar panel to pass through the solar panel, cooling it down when this happens. And it's a unique technology. It's very, very simple, and we're pretty excited about it.
Okay, that's one of your technologies.
Yeah.
And we'll just back it up a little bit. This technology was created by a Queen's professor, is that right? Dr.
Yep.
Stephen Harrison?
Yes, that's correct. Dr. Harrison's the director of the Solar Calorimetric Laboratory. I always get that one wrong. And he's been doing this, he'll hate me for saying this, for about 35 years.
Okay.
And come up with a number of very interesting ideas, and two of them he's gotten patented. And yeah, we work very closely with him on these.
Okay, so the first one you were talking about, there's a patent attached to it, and there's another one that is really emerging, and it involves controlling the temperature in solar thermal collectors, so like a hot water tank, right?
Yeah, so there's the two technologies. The one is, we call it ISC for short, which is integral stagnation control, and that's for the solar panel. The other technology we have, we've short formed it again, it's called PBF, or passive backflow technology. And that relates to a heat exchanger on a hot water storage tank. And both of these technologies combined work very, very well in a solar thermal system. Mm-hmm. But we have taken it upon ourselves to branch that out into other applications in heat pumps, boilers, geothermal systems, things like that.
Okay,
So.
and is that really because there isn't a huge market for the solar thermal systems in this country?
Yes,
Yeah.
I hate to say it, but yeah, unfortunately in North America, solar thermal is not big business. Mm-hmm. The price of electricity, the price of natural gas, also to photovoltaic, the electricity producing panels, they're a lot sexier. They pay you back, mm-hmm. whereas solar thermal saves you money. So it's unfortunate, but I think it will be changing. The climate, the new government putting in more incentives and things like that. So we're optimistic about solar thermal, but our primary focus for it is Europe and Asia at this point in time.
Okay,
so.
because they have a lot more of these systems in place.
Absolutely, yeah. Where their market is growing. The Middle East especially. The largest solar thermal installation is in Riyadh on a women's university. And it's an absolutely massive system providing all the hot water for the entire campus. And things like that are prevalent in Europe. They're becoming more prevalent in Asia. China actually makes up 80% of the world market for solar thermal. So.
Oh, wow.
Yeah, Canada, even the United States are pretty small fish when it comes to solar thermal at this point, but it's growing, and I think people are becoming more aware of it, which is it's very exciting.
Okay, good. Well, it is very interesting technology, so perhaps you can walk us through how it works.
Sure. So the passive backflow technology, which deals with heat exchangers, and they're a very simple technology. Mm-hmm. Where you have two plates and two fluids passing on either side of them. And
one is often water, is it?
Yes,
okay.
Typically potable water that you shower, drink, mm-hmm. everything else that you see in your tank. The other fluid is typically a heat transfer fluid. Sometimes it's an antifreeze if it's going
glycol.
Outside. Exactly,
okay.
a glycol or a refrigerant, so a gas like you'd find in an air conditioning system.
Okay.
And what it does is it transfers the heat between the two fluids, so you get it from the glycol to your shower, so that you can have a nice hot shower every morning. Heat exchangers, this one here is a plate heat exchanger. They're very robust, they're inexpensive to manufacture, they're very small, compact, and efficient, but they have one key design flaw, which is the water that we drink has a lot of minerals in it. And when you heat that water up, those minerals will precipitate out of the water and stick to the sides of the heat exchanger. So as you can see, the plates here are nice and clean and shiny.
This is copper, is it?
Yeah, so that's a copper, and then the other side is a stainless steel, and they get brazed together. What happens is when you start consuming this water, over time, the calcium carbonate will actually stick to the stainless steel on the inside, and you get what you can see here as quite a fouled heat exchanger.
Yes,
so
it's really, it's hard to see on camera, but it's quite kind of gummed up, and this is shale. Is that what it is?
Yeah. So this is the same stuff you'll find at the bottom of your kettle after heating water in it for a couple of years. It's just a white powder. It's limestone, essentially.
And we know over time it really affects the heating elements, and it affects the integrity of the entire structure, doesn't it?
Exactly. Yeah. What'll happen is you'll reduce the flow of water because it will build up. And as you reduce the flow, you reduce the heat transfer, you reduce the efficiency, the system performance, and eventually it will actually plug up completely, which then renders the system useless, and you don't get any
hot water. No hot water, cold showers.
Exactly, which is the tagline that we're sort of using is, hey, no more cold showers. And so what our technology does is it's incredibly simple, and all we do is every time you turn on your hot water to use it, instead of the incoming cold mains water simply going into the bottom of your storage tank as it does now, we divert that water and put it back through the heat exchanger. And what that does is that change in flow and change in temperature cleans this buildup of calcium carbonate and other minerals and flushes them back, redissolves them and flushes them back into the tank, where we happily drink them in our water, and it's good for our teeth and bones.
Okay. Now the trick is, because this already has the buildup, your system won't eliminate it completely. It might help flush it out a little bit. The trick is to have one of these exchangers installed from the get-go.
Exactly.
Right?
This is preventative maintenance.
Okay.
Yeah. Once a system is fouled, it's very, very difficult to clean it without chemicals. Because we don't use any chemicals, we don't use anything, all we're using is the water you're consuming anyway. It's a preventative maintenance step. And so installed at the beginning, it's going to work beautifully for the life of the system. And even within a year or two, I think you'll still get some benefit, but best to do it from day one.
Okay, and that's why when we were saying a few minutes ago, you're really trying to branch out, because not very many people have these solar hot water tanks yet in Canada. So you want to be able to have this on devices that are available in this country that we would have in our households. Yeah,
exactly. So right now we're actually going to begin some manufacturing of our valve in the next 6 months. And what we're looking for is people who are installing geothermal systems, boiler systems, where heat exchangers are more prevalent, or at least like a plate heat exchanger or a tube heat exchanger. And we're looking for installers who have got problems with hard water fouling in their heat exchangers, because we're looking to get real world data from the community, basically, to say, yeah, this is gonna work really well, and we're hoping to launch in the next 6 to 8 months in terms of a beta test in Southern Ontario.
Okay.
So we've got a distributor in Southwestern Ontario right now, and we're hoping to branch that out. Our main focus, as mentioned earlier, is Europe and Asia, though, because they've got the largest markets where these types of systems are used predominantly. Japan, for example, I'd say 90% of their hot water heaters are all heat pumps that use a plate heat exchanger like that. Okay. And they have issues with fouling. So we're hoping.
You were also telling me just before we started the interview that a number of the big players, when it comes to the hot water heaters, they are starting to add the heat pumps to their system.
Yes, absolutely. We just returned from the AHR product show in Orlando, which is the largest HVAC show in North America, and all of the big guys, Sandon, Panasonic, Rheem, you name it, they're all starting to come out with heat pumps. They're starting to see the value in this production. A lot of people also don't know that Europe and the United States have started to ban the production of domestic electric hot water heaters because their efficiency is so low. So in the United States, they've banned, I think it's over 80 gallons. So for most homes, it's not a big deal, but for commercial installations, they've said, we need to show some leadership here in energy conservation, and simply plugging in an electric tank isn't doing that. So we're hoping that that kind of thing is going to really start people into the acceptance of heat pumps for heating water rather than just traditional fossil fuels and electricity.
Now this is a startup really based out of Queen's University. You're trying to get in the ground floor with all of this, this technology changing and the mindset changing of consumers. How has KEDCO helped kind of you along and supported this business?
Well, I mean, KEDCO's been fantastic. They, I think, have really helped to change attitudes in Kingston and the area in terms of looking more forward thinking. You know, they've been pretty crucial in helping us in introductions with companies both locally and internationally, and just really creating an environment that is great for startup businesses that are getting in, as you said, on the ground floor. I mean, it's very difficult to try to change people's minds without a bit of a mass going forward, and KEDCO's really helped us with that. They've introduced us to a lot of services that have helped us get off the ground, and we continue to work with them on a number of different projects because it just has made our lives so much easier. So I think you know, KEDCO's been fantastic in helping us grow and develop as a business.
Good. Well, we wish you the best of luck with your technologies and look forward to how things are going to go in the near future.
Thanks. So I'll absolutely keep you posted.
Thank you.
Thanks very much.
That's all the time we have for this edition of KEDCO on the Street. Thank you for watching. We will see you next time. Bye-bye.